So today we're talking about imaginary numbers and complex numbers. The common core is N for number sense, CN for complex numbers, and it says basically perform arithmetic operations on complex numbers. Okay, that's our common core. 2, 14, 17. All right. So for most of this, we're going to completely treat I like we would an X variable. Okay, so we can add real numbers to real numbers and I's with I's. Okay, so the first one is really easy. It's as simple as this. Nathan, you watching? It's as simple as this. It's just going to be 7 minus 3i. That is your answer. Reals with reals, real numbers with real numbers, imaginaries with imaginaries. Okay? Plus 3i. Yep, plus 3i. Yep. Example 2 is the same thing, except for I have to be careful. I'm going to subtract, right? So 3 minus 4 is a negative 1. And a 5, subtract a negative, double negative, right? It's going to be like plus, so I get a positive 7i. Okay? It's really simple. Now, where we have to be careful is this. We're going to do a little something on the side. I squared is equal to negative 1. I'm going to circle that, and I'm going to highlight that, okay? We need to know that I squared is equal to negative 1. So anytime we get an I squared, we're going to change it to a negative 1, okay? So example 3 is a FOIL problem. 3 times 4 is 12. 3 times negative 2 is a negative 6i. 5i times 4 is a positive 20i. And 5i times a negative 2i is a negative 10i squared. Okay? Well, there's some things we can do to tidy this up. I'm going to combine those two. And I'll change the I squared into a negative 1. Yeah, so I'll go 12 plus a 14i minus 10 times negative 1. Okay. And of course, negative 10 and negative 1 makes a positive 10, right? Agree with positive 10 there. So then 12 plus 10 is a 22 plus a 14i. Okay. Example 4. I to the 23rd. So what I really want is to get some I to the 4th in this problem. Okay, I need an I to the 4th. Somewhere I got to get an I to the 4th in here. So what would be a good multiple?
20.
20, okay. I to the 20th. So if I go I to the 20th times I to the 3rd. Now the reason Marie picked 20 is because I to the 20 is I to the 4th, I to the 4th, I to the 4th, I to the 4th, I to the 4th. And all of those I to the 4th are 1, right? Does that make sense? So I to the 20th is just plain old 1, okay? Because it's just all those 1s, 1 times 1 times 1 times 1 is 1. Now I to the 3rd, if we look at our reading, I to the 3rd is negative I, right? So it's 1 times a negative I. So my answer is just a negative I or a negative 1i. You don't need the 1. I'll put it in there anyway, okay? Okay, not too bad. Now example 5 is a little bit different. In example 5, you're not supposed to have an I in the denominator, just like we talked about it before. So with square roots, the way we fix the problem with square roots is we fix the problem with the problem, right? So what I'm going to do is multiply top and bottom by I over I, okay? So if I need to get rid of the I in the denominator, fix the problem with the problem. So in the top or in the numerator, I'll multiply and I'll get a 7i plus a 3i squared. Okay, you see the 7i plus the 3i squared, okay? 7i plus 3i over a 4i squared.
Why did you multiply the whole thing by I?
Really good question. So there's a rule in math. You can't have square roots in the bottom. And the other rule is you can't have an I on the bottom. Okay? So I've got to fix that. So I get rid of the I on the bottom by multiplying by I over I. And it's going to fix the problem. You'll see why in a second. Remember, I squared is equal to negative 1, right? So I'm going to rewrite this as a 7I plus 3 times a negative 1, right? Because this I squared here became a negative 1. And I'm going to make that I squared into a negative 1 also over 4 times negative 1. How am I doing? So any I squared, we're just going to write as negative 1, okay? So let's see if I can simplify that to 7I minus 3 over negative 4, okay? Now, there's one more thing I want to do. Let's go back to our reading. I got one more fix. In our reading, to be a complex number, it has to be a real plus the imaginary, okay? So we got to separate these, okay? So I'm going to separate these as, ready? I'm going to have an answer of 3/4. You see the 3/4? See the 3/4? Minus 7/4 I. Okay? So I just broke it up into its real number, 3/4 minus 7/4 I. So you get my real plus or minus my imaginary. Okay? And that's the form it needs to be in the right form. Okay? Okay, you ready for example 6? Now example 6 is also like the square roots, where we're going to have to multiply a thing called the conjugate. And you might not remember what the conjugate is, but it's the opposite of the 1 minus 2i. So when we multiply by the conjugate, we're going to multiply by, because there's two terms, by 1 plus 2i. That's the conjugate. So multiply the top and the bottom by a 1 plus 2i. Okay? How's that going to help? Well, let's see what happens. Okay, in the top or in the numerator, I'm going to FOIL. Okay, so I'm going to have a fraction. So in the top, I'll have a 3 times 1 is 3. 3 times 2i is a positive 6i. 5i times 1 is a positive 5i. And 5i times 2i is a positive 10i squared. So I just FOILed the top, the numerator. Now I'm going to do the same thing with the bottom. I'm going to go ahead and FOIL the denominator. 1 times 1, that's easy. That's 1. 1 times 2i is a positive 2i. Negative 2i times 1 is a negative 2i. And negative 2i times positive 2i is a positive 4i squared. Okay, I'll step back and let you see what I've done. So I FOILed the top.
Mr. Davies, wouldn't it be a negative?
4. Yeah, it is negative. Doggone me. Yes. Thank you, Marie. Glad you're here to catch my mistakes. Okay, now, thank you for looking, Marie, and catching my mistakes, huh? So let's see what we have. So I'm going to change my I squareds into negative 1, right? Because I squared is equal to negative 1. So let's go ahead and see what we have. So I've got a 3 plus 11i plus 10 times negative 1, which is a negative 10. You okay with this if I make that a negative 10? That's a negative 1, so that makes that a negative 10. I'll have these two cancel, right? So 2i, negative 2i, I get a 1. And that's a negative 1, so I get a minus 4 times a negative 1. Now all of a sudden if I look at it, I'm not done yet, but the i's are gone on the bottom, which will be positive 4. Yeah, and Marie's right, but before I go any further, what I've done at this point is the i's are gone from the bottom, aren't they? Which is what I wanted to accomplish. No i's on the bottom, there's no i's on the bottom. So let me finish this up. I would have a negative 7 plus 11i over 1 plus 4. So that's just 5, right? So I have a negative 7 plus 11i all over 5. Am I going too fast? Okay. And now finally, that's an I. It's a bad looking I. It's an I. Finally, we've got to write it as a real plus imaginary. So we separate these to a negative 7/5. Come on, pen. Plus 11/5 I. Okay, so all we're doing is manipulating I. That's what we're doing. So like the common courses perform arithmetic operations on complex numbers, we've done that. But let's turn the page when you're ready, okay? So now let's use this information to solve, okay? So example 7. Okay, this will not factor. It will not factor. Okay, if you try and factor it into x plus 3, okay, real quick, I want you to show you this. This will not factor. X plus 3 will give you a middle term of x squared plus 6x plus 9, okay? So this will not factor. So what do? We try and solve it. So I'm going to bring over the 9, subtract the 9. X squared equals negative 9, right? 2 answers. Has to be 2 answers because of the x squared. Has to be 2 answers. One's going to be a positive and the other's going to be a negative answer. Yes, we'll do plus or minus. So we take the square root of both sides. And we get x equals plus or minus the square root of negative 9. Okay, so far does that make sense? Square root, has to be 2 answers, positive, negative answer, right? And we saw over here why you have 2 answers, positive, negative answer, right? Now the next piece is this. It's got a negative square root. So let me rewrite this as x equals plus or minus the square root of 9 times the square root of negative 1. Okay? Because 9 times negative 1 makes negative 9, right? This is I, isn't it? This is I. So my answer, x equals plus or minus 3i. And the 3 came from the square root of 9. And the negative 1, square root of negative 1 becomes the I, okay? Thumbs up? Okay, not too bad. Did you guys see this last year in Algebra 2 or last semester? Okay, hopefully this is a review. Okay, example 8. Bummer. I don't think it factors. So what do we do if it doesn't factor? Minus b plus or minus square root b squared minus 4ac all over 2a. Now somebody's going to say, Mr. Davies, why don't you just use your calculator? All right, I could use my calculator. If I want to have the answer, I could go, first of all, I can go to my poly root finder, right? Degree 2, right? And I go 4, negative 24, 37, solve. Uh-oh. So my calculator won't do it. I could try graphing it, but I already know what's going to happen if I graph it. I already know the graph is going to look something like this. It's going to look something like this. So if you're looking for the x-intercepts, right, or the zeros, you're not going to get it. So what do? Calculator doesn't work. A graph won't work. I think we're going to have to use the quadratic formula. I know the answer is going to be an I answer. So you ready? Let's tackle it, all right? So A is 4, B is negative 24, and C is 37, right? And we're going to have to use this darn quadratic formula. So negative B, which is a negative 24, plus or minus, and hopefully you know where the plus or minus comes from because there's 2 answers, right? Plus or minus square root of b squared, which is a negative 24 squared, minus 4 times a, which is 4, times c, which is a 37, all over 2 times a, and a is 4, okay? You're going to have to do this on the test Friday. But it's just abstract multiply and divide. That's all it is. You guys agree? It's all the quadratic formula is just abstract multiply and divide. That's it. So you ready? We're going to have a positive 24 because of the double negative, right? Plus or minus square root. Oh, 24 squared. First of all, before I say anything, it will be positive. Don't make a mistake. Any negative squared is always positive. Always. Negative times a negative, right? So 24 squared. Don't make that mistake on the test. 576 minus, let's see, what's 4 times 37. I get 592 all over 8. Okay, how am I doing? Minus 576. So, let's keep going. 24 plus or minus, well, this turns out to be a negative 16. 576 minus 592 is negative 16. All over 8. Now, right off the bat, I already know it's going to be an I answer. It has to be because of the negative 16, right? Take the square root of a negative number, it's imaginary, okay? So what is the square root of 16?
4.
And then we're going to have a 4i. You okay with the 4i? So what we're really going to have is 24 plus or minus 4i. I over 8, okay? Which would be the same thing as 24 eighths plus or minus 4 eighths I. Okay, so I just broke it up into two parts. They're both being divided by 8, right? 24 over 8 is 3 plus or minus 1/2 I. That's the answer I want. Okay? All right. So today's homework, page 64, so we're going to go way back to chapter 1. 19, 20, 31, 40, 43, 48, 55, 57, 61, and 71.